Today we will discuss tempering. Tempering is a heat treating process used for metals. Specifically, we will discuss steel today. Tempering is a process used to improve toughness, but it also decreases strength and hardness. Today we will discuss mechanical and microstructural changes during tempering, as well as the formation of various distributions of carbon, carbides, and iron.
One stage of tempering, which we will refer to as stage 1, takes place at up to 250 degrees Celsius. This results in carbide rod formation. These carbide rods will stop forming when the martensite is about equal to 0.25 weight% carbon. There is a modest increase in toughness with high strength and fatigue resistance.
The second stage of tempering is at the temperatures 200 to 300 degrees Celsius. At this temperature, the retained austenite will decompose into ferrite and cementite, and pearlite will not form at this temperature.
Stage 3 occurs from the temperatures 200 degrees Celsius to 350 degrees Celsius. The carbide is replaced by cementite, and martensite plus cement plus the carbide decomposes to ferrite plus cementite.
The last stage of tempering we will talk about today is at the temperature greater than 350 degrees Celsius. At this temperature, there is a reduction in surface energy, which is caused by the coarsening of cementite and spheritization of cementite as well. Basically, the pinning effects are reduced as the number of particles decrease and the size increases. Recrystallization and recovery of ferrite also occurs at this temperature. Basically, the precipitation of carbides leave a very high dislocation density.
Embrittlement is one problem with tempering. This is because of phosphorus segregation at the austenite grain boundaries. This results in intergranular fracture through one of two methods. Tempered martensite embrittlement happens when phosphorus segregates during the austenization. The retained austenite decomposes between martensite laths, resulting in a continuous cementite film. Temper embrittlement happens when phosphorus segregates during tempering.
Alloying affects tempering quite heavily. It can affect the phase stability, the austenite decomposition, the carbide precipitation. It can also increase hardenability and decrease the martensite start temperature.